Okay, so given an array like this, so all we are going to do is start again similar to the previous algorithm, start with one index, and but here you are going to just compare it with its immediate right. So start with 45, compare it with 78. Now if again we want to sort it in the increasing order, so if the element to it at the left is less than the element to its right, we keep them as it is. So 45 is less than 78, so keep them as it is. Then 78 compared with 23, let me write here and explain, it's more easier. So we're doing the first iteration, so let us call it as iteration 0. So we start with 45, then let me write down the entire array. Right, so within iteration 0 we go through this. We compare 45 and 78. 45 is less than 78, so keep it as it is. And the rest of the array will look like this. So in the slide I am not showing this level of detail, so I am working out now here. So we're done with comparing 45 and 78. So now the same array, compare the next two elements, which is 78 and 23. So when you compare 78 and 23, we see the left element, which is 78, is not less than 23. It's not less than or equal to 23, the right side element. So if the array has to be sorted, this is not the right way the two values should be, because 78 is on the left and is greater than 23, the element to its right. So we have to swap them. So the array becomes 23, 78 and 12, and then the rest is as it is then. So we compare these two index values. So now compare the next two index values, so which is these two index values, 78 and 12. So again, when you compare them, we'll notice that the element to the left is greater than the element to the right. So that means we have to swap them. So 45, 23 as it is, then 78 and 12, 78 will go to the right, and 59 and 72. So then what we do, we compare these two elements and swap them. 78 with 59, again 78 is greater than 59, so we need to swap them. So becomes 45, 23, 12, 59 and 78, and then 72. So in the last step we compare these two elements, and again 78 is greater than 72, so we swap. So at the end of this iteration, we are going to have something like this. So you notice that we started with this array 45, 78, 23 and so on, and for that let me type the input array. So we started with this array, and at the end what happened? The largest among the elements in the array has moved to its right, or to its final position. So the largest among these elements is 78, and that element has moved to its final position, which is this position 78. So that's the first iteration, or that's one iteration. Okay, so at the end of the first iteration we have what is called an unsorted portion, which is everything from index 0 to n minus 2, and then we have a sorted portion. which is just this 78. So initially the entire array is the unsorted portion, there is no sorted portion. So after the first iteration, which we call iteration 0, we have the largest element in the array moved to its final position, and that's the part of the sorted portion, and the rest is unsorted. So we repeat this process in subsequent iterations. So iteration 1, we repeat this process, but only for the unsorted portion. We don't touch the sorted portion. So we take this array and go through the same process, but do all the pairwise comparisons only in the unsorted portion. So that means we'll start with comparing 45 and 23, and 45 is greater than 23, so we have to swap them. Now if you could visualize it, you could actually compare like this, 45 with the next element 12, instead of writing all these stages. So that's why I wrote in the slide just one step, the final step. You could do that in the exam, because you don't really have to show all these intermediate steps. You can compare it like this. Let us do that. This 45 compared with this 12. So again 45 is greater than 12, so which means 12 has to go here and 45 has to come here. Then 45 compared with 59 pairwise, 45 is less than 59, so 45 could be here. Then 59 compared with the element to its right, which is 72. 59 is less than 72, so 59 could be here. Then 72 need not be compared to its right, because we are sure that that's the sorted portion, so which means the largest element has moved there to its final position. So 72 is really the last element in the unsorted portion, and it has moved to its final position in the final sorted array. So that means 72 can also be now considered to be part of the sorted portion, which is this, as well as the 78, which is the part of the sorted portion. So this is how the array contents are at the end of iteration 1. So you can see the unsorted portion has decreased by 1 element, and the sorted portion has increased by 1 element. So the sorted portion now has 72 and 78. So again, basically you can see in the unsorted portion, the largest element has what is called bubbled all the way to its final position, which is this 72. Okay. Any question on this so far?
No, sir.
Alright, so let us continue the next iteration. So we take up the array at the end of the previous iteration. So you work on the same input array, there is no need to create a separate memory block of elements and so on. We can do everything on the input array itself. So now 23 compared with 12, 23 is greater than 12, so swap them. So you have 12 and 23. Now 23 compared to the elements to its right, so 23 with 45, 23 is less than 45, so that is fine. So we kept them as it is. So now 45 compared with to its right, 45 is less than 59, so that is fine, you can keep them as it is. And 59 is really the last element in the unsorted portion, we don't need to really compare it to its right. So it means for 59 that's its final position, like it happened for 72. So we can make it to be part of the sorted portion now, and write down our 72 here as well as 78. Those are also part of the sorted portion. So you can see at the end of this iteration, the unsorted portion has reduced by 1 element, and the sorted portion has increased by 1 element. So let us do the next iteration. So we have like this 12, 23. So now compare again 12 is 23, 12 is less than 23, so 12 could be as it is there. Then 23 with 45, 23 is again less than 45, so no need of swapping. And for 45, that's its last position. So that means final position, that means it's also part of now the sorted portion. So we keep it as it is there and write down the rest of the elements. Now when we did this iteration number 3, we did not do really any swapping because we compared 12 to 23. There's no need for a swap. 12 is less than 23, so we wrote the 12. Then compared 23 with 45, there's no need to swap, so kept 23 as it is, kept it there, and then write 45 here. So there was no need of any swapping in this iteration. That means, and again we did all the comparisons in the unsorted portion. In the unsorted portion, there is no need for any swapping. That means for every pair we compared, the element at the left was less than or equal to the element to its right. So if that is the case in the unsorted portion, that means the unsorted portion is also sorted by now. Right? So when you compare 12 with 23, there is no need for swap. 23 with 45, no need for a swap. And that's the last element, 45. So in the two comparisons in the unsorted portion, there was no need for any swap. That means the unsorted portion that we had to begin with in iteration number 3 is already sorted by now. So what we end up having here is the final sorted array. Now if there was at least one swapping that was done, we need to go through few more iterations. So it's iteration 4, and of course you know what is the unsorted portion size we will be working with. In the iteration 3, we work with the unsorted portion of size 3. In iteration 4, we'll have an unsorted portion of array of portion of size 2, and that's the last iteration, because after that we'll have the unsorted portion of just one element, which is considered to be also sorted by itself. So that's what I show here. In iteration number 3, there was no need for any swapping, so we can stop the algorithm and there's no need to go through the remaining iterations. That's a kind of optimization of this bubble sort algorithm for this pairwise comparisons. So before that, so any questions? Okay, so that means what is the best case for bubble sort? So we do the pairwise comparisons, and if there is no need for any swapping in one iteration as we go from left to right for all the pairwise comparisons, that means that, and again we do all the comparisons only in the unsorted portion, so that means the unsorted portion is sorted if there's no pairwise, if there's no swapping needed for any pairwise comparison. So this can happen if the input array, if the given array itself is already sorted. So if I already gave you the sorted array, something like this, we go through one iteration and go through all the pairwise comparisons. So compare 12 with 23, leave So compare 12 with 23, 12 could be there, then 23 with 45, 23 could be there, 45 with 59, 45 is less than 59, 59 less than 78, 78 less than 90, and 90 is the last element, so it's there. So there's no swapping needed in any pairwise comparison in this iteration, so you can say the array is already sorted. So that's the best case of going through just one iteration. That's the best case if the input array is already sorted in the forwarding order, and that's the order of sorting we want. Now if the input array is reverse sorted, in the sense that if the array is like this, and we want to sort it in the increasing order, this is the case where you would encounter the worst case number of comparisons. So think about this. For iteration 0, if this is input array, we would compare 90 with 78. 90 is greater than 78, so swap them, and 78 goes here, 90 comes here. Then compare 90 is 59, 90 is greater than 59, so 59 goes here, 90 comes here, we did the swapping. Then 90 with 45, 45 is 90 is greater than 45, so 45 and 90 are swapped. Then 90, 23, 90 is greater than 23, so swap them, so 23 comes here, 90 goes here. 90 compared with 12, 90 greater than 12, so again swapped it. So at the end of the first iteration, or iteration 0, the largest among the elements in the unsorted portion, which is the entire input array, has bubbled all the way to its final position, which is this 90. So we have sorted portion, and this is the unsorted portion. So in the next iteration, repeat this process. So we will have in iteration 1, '78 compares 59, 78 greater than 59, so swap them. Then 78 45, 78 greater than 45, so swap them. Then 78 23, 78 greater than 23, so swap. Then 78 12, 78 greater than 12, so swap. And that's the last element in the unsorted portion, so we can say 78 has bubbled all the way to its final position, and that's its position here, and then 90. So this is the sorted portion, the 78 and 90, and that's the unsorted portion. So the next iteration, you will notice 59 will bubble all the way to its final position, and so on, like this. And then 45 will go all the way to its final position, and then between 23 and 12, 23 will go to its final position. So if the array is reverse sorted and we want to sort it in the increasing order, then we need to go through all the iterations, and that's the worst case time complexity scenario. So in order to analyze the best and worst, the best case and worst case, we have to look at the pseudo code, which is based on really the algorithm that we went through, the example, and then we'll look at the time complexity. Let me check the time. It'll just say